Okay, we're going to look at solving systems of equations by graphing. And all a system of equation is some sort of situation like we have here, where I have multiple equations, and I want to try and find where those equations where they are going to be equal to each other, essentially. So when can I plug in a value for x, and I plug in a value for y, and they both give me some sort of true statement. And really, one of the easier ways to do this would be to take your linear equation, in which case we have two of them, graph them. So put them into y equals mx plus b form and throw them onto a graph, and then wherever they intersect, that point will be the solution, the x, y solution of your system of equations. And I've got an example here that I just want to walk through. But like I said, the first thing you got to do is find your y equals for both of them. We want to put them into that y equals mx plus b form that we're familiar with and we're comfortable with. So we can find the slope, we can find the y-intercept, and then we'll actually be able to graph them. So looking at this first one here, I've got 4x minus 6y equals 12. I could do this a couple different ways, but the way I decided to do it is to solve for my y, and I want to get a positive y. So I added 6y on both sides. So plus 6y and plus 6y. And that looks bad, so I'm going to erase it. But we added 6y on both sides, which gave me just my 4x over here. Didn't change anything. Then over here now I have a positive 6y plus 12. Makes it easier now because my y is positive. I don't have to worry about dividing by a negative. My next step would be to get rid of this 12. To get rid of this 12, I need to subtract 12 on the right hand side, which means I've got to do the same thing and subtract 12 on the left hand side, which gives me 4x minus 12 on the left hand side equals 6y on the right hand side. Now I could flip it just to make it look better, more presentable. So I've got my y on the left hand side now, I've got my x and my constant on the right hand side. Then the last thing I got to do is get rid of this 6. To get rid of this 6, I'm going to divide by 6. So I'll divide by 6, and which means on the right hand side I've got to divide both sides by 6. You can see here I'm going to be left with y equals 4/6 x minus 12 over 6, which is going to simplify down to y equals 2/3 x minus 2. So my m, which is my slope, is going to be that number I'm multiplying x by, which is my 2/3, which means I'm going to rise 2, and I'm going to run 3, and then my y-intercept is going to be a negative 2. That means on that y-axis it will be at the point y equals negative 2. Now that's just my first line, so my first graph, my line, I've got my information. Now I'm going to essentially do the same exact thing for the second line. So I'm going to go through here, and I'm going to solve for y. I want to get y alone. First thing I'm going to do is subtract 2x from both sides, so I get rid of this 2x. Bring it over to the other side, I've got a negative 2x now. So I have 2y equals negative 2x plus 6. To get rid of this 2, I've just got to divide by 2. So I divide the whole thing by 2. Divide by 2, and divide by 2. Which is going to simplify down to y equals negative 2x over 2 plus 6 over 2. If I simplify that one more, I get this y equals negative x plus 3. And this is important. When you see that negative x, we still have to remember that there is a negative 1 that's being multiplied by that x. Can't see it, but it is there, which remember is a negative 1 over 1. So instead of rising now, we're going to fall 1 and run 1. So I'm going to fall one and run one, which accounts for this negative slope. And then my y-intercept is going to be a 3. So I'm going to start at 3 and I'm going to go down 1 over 1. Okay, so if we look at essentially what my graph would look like, we can see here my red is going to be my line that was y equals negative x plus 3. And my blue was the line that was y equals 2/3 x minus 2. Look back at the last one. I have my 2/3 x, 2/3 x minus 2, negative x plus 3. So look at this page, I got my 2/3 x minus 2, I've got my negative x plus 3. So we'll do the red one first. Red one, I've got a y-intercept of 3, so I'm going to map that first. I can put my dot there at 3, and then I'm going to go down 1 over 1. And I can create that line that goes right along this red line. Remember, down 1 over 1. For my blue line now, I can see that I should start at negative 2, and it's going to go up 2 over 3. So up 2 over 3. I can put a point here. Once I have 2 points, I can connect it and create a line. Now, the whole point of this was to solve this system of equations. To solve the system of equations, we want to find where those two intersect. And we can see that intersection point is right here. And x, y, that is 3 in the x, 0 in the y. So my solution is going to be x equals 3, y equals 0. Now I can go back through and I can check it. So these are my original equations. And if I check that, I should see that I get two true statements. So if I plug in 3 for x and 0 for y, you can see on this left equation I'm going to get 4 times 3 minus 6 times 0 equals 12, which is 12 equals 12, which is true. And on the right one, if I plug in 3 for x, 0 for y, I'm going to get 2 times 3 plus 2 times 0 equals 6. So I'll get 6 plus 0, 6 equals 6. Again, that is true as well. So my intersection of these two lines is going to be my solution to this system of equations.